Hello and a very warm welcome to the world of material sensing. My name is Robert Langer, and in this video we would like to take a closer look at the Senorics technology in comparison to other technologies used for spectroscopy and material sensing. And here with me to discuss these questions is our CTO, Dr. Robert Brückner. Hi.
Hi, Robert.
Hi. So let's start on a higher level and let's start with the spectrometer as a system, because our technology here at Senorics works quite differently than a classical spectrometer. Can you explain us how?
So a standard spectrometer is composed of several optical components. First you have the entrance slit, then you have some kind of dispersive element which disperses the white light into the different spectral regions, and then you have usually a broadband detector or a detector array. And what we did at Senorics is we merged all of these components into one single device, and we end up with our planar systems with all the power in this planar device.
Okay, so this is basically not only a detector, it's even more than that. You can almost call it a spectrometer on chip level, right? Okay, so then let's dig a little bit deeper regarding this spectrometer on the chip level. One of the most important things that also people know from the spectrometers they have in their lab is the detector material, and two names come to mind immediately because they're very common. One is silicon and one is a material combination called indium gallium arsenide. What are they? What are they used for? What are the strengths and weaknesses?
These are the absolute standard materials. Silicon for the visible spectral regions up to about 1000 nanometers. You can do very powerful spectroscopy, and it's very cheap material. And when it comes to NIR spectral region, you need to go to indium gallium arsenide, which is a very expensive material because it's epitectically grown, and it's not so scalable than, for example, silicon.
Okay, so we have differences like in costs and differences in wavelength coverage. But to me, it seems one of the most distinguishing features to our technology is the broadband detection capabilities. Yeah. Now, what kind of effects does that have, and how is that limiting silicon and indium gallium arsenide when it comes to building compact, robust, miniaturized spectrometers? So
first, we mentioned already the spectral or all the ingredients which are necessary to take a spectrum, the spectrometer. This is all in here, and then the different spectral regions are more for the different applications. So for visible spectroscopy, you go with the silicon detector, and for NIR spectroscopy, for material sensing, it's better to go to indium gallium arsenide. And we at Senorics, we have a clever material compositions of our organic materials, and we can cover the entire spectral range of silicon and indium gallium arsenide, and we can combine it into one single chip covering both spectral regions.
So as you just described, silicon and indium gallium arsenide, they are broadband absorbing materials. We have a completely different approach. How is that approach different, and what is it actually? What is this approach?
So we are neither using silicon nor indium gallium arsenide. We are using this organic material in combinations out of organic materials. This is the first big difference, and the second difference is we are not broadband. So we can really tailor our spectroscopic resolution to the spectral regions we need it for. So the requirements, they come from the application itself. So we can put spectral resolution into the visible spectral region, we can put it into the NIR, we can combine it. So we combine also the words of silicon and indium gallium arsenide, and without dispersive elements.
Okay. So that sounds like a big step forward. On the other hand, I'm assuming that those materials, they are not obsolete as of now. They still have their use in specific applications. Even with the new kid on the block, there would be the Senorics technology. Now, where would you say in the future, where will we still find silicon and indium gallium arsenide based devices?
I think when it comes to lab spectroscopy, these technologies are quite perfect. They are highly performing, and in our technology, in comparison, can be more robust, and we can also get robustness by having not so high requirements on our on the spectral features and so on.
Okay, so that means with our technology, with the Senorics technology, we can open up new possibilities, can open up new markets, new applications, right? That basically take stuff out of the lab. What comes to mind? What comes to your mind as a CTO when you think about markets and applications?
Yeah, it would be cool to have it in a handheld device as it is here. So it's equipped with 16 pixels, and you can go out and take measurements. So for example, you can go to the agri-food market, to the fields. You measure plants when they are growing there. This is not possible so far.
Mm-hmm. But is it only the size? Is it only, that all of a sudden, based on Senorics technology, you can make it rather small? Because there are other companies out there that are producing small spectrometers, or is there more to it? Are there other advantages where you say, okay, no, these markets, these applications, they're only possible with Senorics?
So again, it's small, so this box is basically full of air, so there's nothing in there. It's low cost, it's quick. We can scale it easily to really large amounts, and yeah.
Mm-hmm. So in a nutshell, basically, is ideally suited. Our technology is ideally suited for B2C applications or large volume.
Exactly.
Whenever it's not a niche, whenever it's not very, very specific, where you need high precision and where you need a kind of a Swiss Army knife spectrometer, but more when you have tailored, when you only need a knife and not a corkscrew or a screwdriver, you can basically use this device, because then you're better suited.
Yeah. Right.
Okay, interesting. So so this concludes our video here about the comparison between the Senorics technology and competing technologies or different technologies such as silicon and indium gallium arsenide. And if you want to learn more about different topics, about the world of material sensing, then feel free to visit our website at senorics.com. Check out our social media channels on LinkedIn, YouTube, and Facebook. And also subscribe to our free Explore and Understand package that you also find on our website. So in this sense, thank you for watching and happy analyzing.